Hey guys, welcome back to another video. Today I'm going to be taking on LeetCode 905 Sort Array by Parity. This is as part of my raw and authentic LeetCode walkthroughs playlist where I try to solve problems raw and authentic without looking at the answers beforehand. So this is an easy problem and let's give this a go. Given an integer array nums, move all the even integers at the beginning of the array followed by all the odd integers. Return an array that satisfies this condition, any array that satisfies this condition. Okay, so essentially 3, 1, 2, 4, 2, 4, 3. Okay, so you just take the odd numbers, you move them to the side, outside. Okay, all of these work too. If there's just a 0, okay, beautiful. Okay, so like the first way, well, see, the thing is, the first way that I think of is like, oh, go for num in nums. Like, this is probably what a lot of people will think of, but I think there might be a problem with this because of the shifting of elements, because you're going to remove num. Okay, wait, sorry. I should probably like make this more. So let's go through the list, right? If a number is odd, we probably want to remove that number, and then we want to add that number to the end of the list, right? So if num, to check if it's odd, you just check if dividing by 2's remainder is 1. So that's the modulus operator. So if num is odd, essentially, we remove num, and then we do nums dot append num, and then we return. Let's see. Okay, I don't think this should work though, and I'll explain why in just a moment. Let's see. Yeah. Okay. Yeah, okay, so essentially what's happening is it's skipping elements because essentially what's happening here is, so the loop is going through this, right? So it's gonna see the 3 and it's gonna be like, oh, this is true, so we're gonna remove 3 and we're gonna append 3 to the end. But what happens is this entire list shifts down. So now 1 is at the start. But the loop is seeing this list by index, and so when it sees that it's done the first term, even though it's a different term now, even though 1 is now moved to here, it's going to be like, now let's go to the second term, and that's going to be this 2 here, because the whole thing is shifted down. So because of that, the 1's going to get left alone, and nothing is going to change. That's why it's left here in the output. So that's why this solution doesn't work. So let's think about maybe like another way to do this. Okay, so we know we're working from two ends, kind of, right? Like, we want to move everything either to the left or to the right, kind of, like certain numbers to the left or the right. So this kind of indicates like a two-pointer approach, but let me just give this some thought. So two-pointer on either end. So let's imagine what that would look like. So if we had a pointer on either end here, and then, well, what cases could we have in that? Okay, so we have a right and a left pointer. Okay, let me make some space here. So we have a right and a left pointer. So there's a few cases here. Okay, let's say both of them are odd. Okay, let's think about this. So if they're both odd, what would we want to do? Okay, wait, I'm going to change these just because having left and right on opposite sides is kind of confusing. Okay, wait, the main... okay, let me actually cover this case later. Let's do this case first. So if we have left and right, if the left side is odd and the right side is even, then it would be pretty cool if we could like swap them, right? If the left side is odd and the right side is even, then we should like swap L and R, right? I'm gonna like, yeah, okay. I'm gonna like delete all this, but like, okay. Okay, so if the left side is odd, what about if it's the other way around? If it's even and odd, then we shouldn't really do anything, right? What should we do? If the left side is even and the right side is odd, then that's perfect. That's exactly what we want. So what we could do is we can increment L, and we can decrement R. Okay, now what if they're both odd? Well, the right side is good. We want the right side to be odd. That's perfect. The left side is not good. We want the left side to maybe be moved. Unless all of the numbers between are odd, if there's even one even number, then eventually, okay, so what I'm thinking is we just decrement r if both are odd, because this number is good. We're good with that. But let's say there's an even number that's sitting right here. There's an even number that's like right next to it. Well, then let's move to this one. And now we're comparing these. What do we do in the case when it's odd and even? We swap them. So then we'd have an even and an O, which is exactly what we want, right? So this case checks out pretty well. And then what happens if we have two evens? Well, it's the exact same thing, just the other way around. This is perfect. This, not so much. If we could move this down to this end or next to it, let's say we have an O here, then we could be like, oh, oops. Like if we have an O here, then we'd be like, okay, well this is perfect. We want the evens on the left side. So let's just ignore it and let's just move down. Now we have an odd here. Now we're in this case again. So let's swap the L and the O. Bang. And then we have all the evens on one side and all the O's on the other side. So in the case where we have two evens, we just increment L. We just increment L. Okay, wait, this actually like works out perfectly. This I think this logic makes a great deal of sense. So our first one is L, which is going to be 0, and then R is going to be length nums, length nums minus 1, so that will put it at the very end. And then we'll say while, let's think about this. So in this case, we'd have a 3 and a 4. So this is odd, this is even, so we're going to swap them, and we're going to move both in. So we're going to have 1 and 2. Then what's going to happen is we are going to have, what's going to happen is we're going to have 1 and 2. This is odd, this is even, so we're going to want to swap this too. And then they're both going to be past each other, if that makes sense. So I think we can say while L less than R. We don't have to say equal to, because if you think about it, if both indices are on the same value, then what ends up going to happening is it's going to be one of these two cases. Either the number's odd or the number's even, and in that case L is just going to get incremented, and even if it is equals to, this is still eventually going to, even if it's equal to, it's just going to be one more iteration, and then this will be true. So I think this is okay. We can just leave it as that. So now let's write each case. So if we have so left side is odd, so nums L is odd, so equals to 1, and nums R is 0. Then what we do is we swap L and R. So we say nums, let's set like a variable, so let's say like left equals to nums L, and then we can change nums L. We can change nums L to nums R, and then we can change nums R to that variable beforehand. So left. Okay, beautiful. Now, elif we have an even. Wait a sec. Oh wait, I made a mistake here. If this side is even and this side is odd, we actually don't do anything. Oh wait, oh no, sorry. Oh no, we do bring both then. But we also do it here. Yeah, that makes sense. We also do it here. Okay, beautiful. So L plus equal 1, R minus equal to 1. Then we have else if, I'll just copy this and let's change these. So now this is the case where R is odd. So this is this case. All we're going to do is this, and that's all that matters. So oops. So let's go ahead and take this, and we're just going to put that there, and then elif. Next we have both are odd. Okay. Let's copy that. Let's get this case in. So both of them are odd. Then what we're going to do is we're just going to r minus equal to 1. And then if both are even, then we're just going to increment L. I guess I don't even have to say this. I can just say else, because if these are all the possible scenarios. So if it's none of these three, it has to be this. So we can just say else for this. I believe so, at least. Okay, let's see how this looks now. So if I return nums, now how does this look? Let's see. I feel like the logic checks out, but maybe there's certain cases where it doesn't quite work. I'm yeah, I can't have that in the solution, unfortunately. Okay, beautiful. Nice. Okay, this works out really nice then. So I'm gonna submit this and hopefully this works. Let's see. Oh wow, that's awesome. Okay, let's compare our submissions. Oh, I didn't submit that one. Oh yeah, no, I'm I'm not thinking about that right. I was thinking the previous answer where I said like for num and nums remove append. I thought I submitted that, but that didn't even work. I forgot about that. So yeah, but this seems to be pretty good on runtime. Space maybe could be a bit better, but I mean it's not horrible. It's kind of sitting around where everybody else is. But yeah, that should be the end of today's video. If you guys learned something, please let me know down in the comments below. Also, if you think there's like a better way to solve this, do let me know. I'll definitely check that out. But that's the end of today's video. I hope you guys enjoyed, and I will see you in the next one. Bye-bye.